Assalamu alaikum and welcome to Mathcast with Faria Yusuf. And this is the fourth lesson of trigonometry, which is for identities. So, what is identity? Identity means it's a result which is true for any value of a variable. It's a result that is true for any value of a variable. Meaning, in simple algebra, if I say it's x plus x, which equals to x. So this then in terms of variable becomes an identity. This is an identity here. So in trigonometry, we shall be using two identities which are very much related to the P1 course. The first identity we have already discussed is that tan theta is actually the ratio of sine theta over cos theta. So this here is the identity. So just to give a quick recap of how we get tan theta equals sine theta over cos theta, we know that tan theta is the ratio of opposite over adjacent, and sine theta is the ratio for opposite over hypotenuse, and cosine theta is the ratio of adjacent over hypotenuse. So that means if I take the ratio of sine theta over cos theta, then this becomes opposite over hypotenuse divided by adjacent over hypotenuse. So hypotenuse gets simplified here. Hypotenuse it gets simplified, and we are here left with opposite over adjacent, which is actually the tangent ratio. So here we have shown that tan theta is actually the identity which is equal to sine theta over cos theta here. The second identity that we shall be using a lot in this course is regarding the Pythagoras theorem. So with respect to the Pythagoras theorem and trigonometry, so let's say we have this circle here with respect to the y-axis and the x-axis, and we have this rotation angle. So if I drop this perpendicular, then what we know here is that with respect to this angle, which is theta, this is my hypotenuse, this is my perpendicular, and this becomes my base here. So with this as the base, we know the Pythagoras theorem. So the Pythagoras theorem, it states that hypotenuse square equals perpendicular square plus base square. So again, I will be using the identity for the sine and the cosine ratio. But before that, I will be dividing this whole Pythagoras theorem by hypotenuse the whole square. Meaning I can say it's h square, which is equals to p square plus b square. And if I divide each and every term here by hypotenuse square, then what I'm getting here is a 1, and this is p over h perpendicular over a hypotenuse the whole square plus b over h the whole square. We know sine theta is the ratio for opposite or perpendicular over hypotenuse, and cos theta is the ratio for base over hypotenuse or adjacent over hypotenuse. So in place of perpendicular over hypotenuse, I can simply substitute sine theta as a squared value, and in place of base over hypotenuse, I can substitute cos theta as the squared value. So this is another very important identity that I have here, which says that it is sine square theta plus cos square theta, and that should be equal to a 1. So this is the second identity which we shall be using in this topic to prove the two sides, right hand side and the left hand side, and to prove the two identities. So again, repeating and recapping the two basic identities that we shall be using. Number one, it's tan theta, which shall be equal to sine theta over cos theta, and it's sine square theta plus cos square theta, which is equals to 1. And from this identity, if in some of the places I might also be saying that it's sine square theta, which is equals to 1 minus cos square theta, or cos square theta here can also be written as a 1 minus sine square theta. So these are the few identities that we shall be doing and using to solve all the equations for identities. So let's start solving some questions. Question 1. Express in terms of sine theta, sine square theta minus cos square theta. So for the solution of this question, if they are saying express sine square theta in terms of sine square theta minus cos square theta in terms of sine theta, then this means that basically we have this cos square theta which shall be substituted by some other expressions to convert this whole expression in terms of sine theta. That means here I can very easily say that this is sine square theta minus cos square theta then can be written as a 1 minus sine square theta. I can see that the entire equation now is in terms of the sine theta, or I can say it's a sine square theta minus 1 plus sine square theta, and further I can say it is 2 sine square theta and a minus 1. So this is how I can express the equation or the expression in terms of one trigonometric value. Simplify part A, 1 plus sine theta plus cos square theta divided by 1 plus sine theta. So for part A, we have 1 plus sine theta plus cos square theta over 1 plus sine theta. If we need to simplify this expression, then simply what I can see here is that I can substitute this cos square theta with 1 minus cos sine square theta. So I can simply say that this is a 1 plus sine theta cos square theta replaced by 1 minus sine square theta, and this is then all divided by a 1 plus sine theta. So 1 minus sine square theta, if you remember the identity, the algebraic identity which says it is a square minus b square, then this a square minus b square is written as a minus b and a plus b. So in this question, I can see that this 1 can be written as 1 the whole square, so that I do have this identity as a square minus b square, which now can be replaced as a minus b and an a plus b. So substituting the values, I can say it's a 1 minus sine theta and 1 plus sine theta. And this is all then divided by 1 plus sine theta here. I can simplify this 1 plus sine theta, and here what I see is that I'm left with 1 plus sine theta plus 1 minus sine theta. Sine theta and negative sine theta, they also get simplified, and my final answer becomes a 2 here. So this is going to be the simplified expression or answer for this question. Let's do part B. So to start the simplification, I can see I have a sine cube theta here and a sine theta here. That means sine theta can be taken as common. So if I take sine theta as a common, I will be left here with a sine square theta plus cos square theta, and all of this is then divided by sine theta. Again, the sine theta gets simplified and I'm left with sine square theta plus cos square theta. So we know the identity for sine square theta plus cos square theta, that is equals to a 1. So the simplified answer here is going to be a 1. So this then is going to be the answer. Now let's prove some identities. Part A, tan theta should be equal to under root square root sine square theta divided by 1 minus sine square theta. So if I start solving the right hand side, which is sine square theta divided by 1 minus sine square theta square root, therefore I am taking them to the power of 1 by 2, then what I see here is that we have a sine square theta. 1 minus sine square theta can be written as a cos square theta. We know that 1 minus sine square theta equals a cos square theta. So I'm using this identity. So 1 minus cos square theta, and then this is all to the power of 1 by 2. Now, what I can see here is that it can be a sine theta over cos theta the whole square, and this is again to the power of 1 by 2. So the square gets simplified. Now we know the identity, sine theta over cos theta, this equals the tangent theta. Therefore, this can be written as a tangent theta, and we can see here that the left hand side is actually a tan theta. That means now I can say that it's the left hand side which is equals to the right hand side, and we have proved the identity that the two sides, they are going to be equal. So this is going to be proved here. So part B, we have to prove that. Now again, see this symbol, this represents the identity. This represents that the two sides, they should be solved separately. We cannot bring anything from the left side to the right side, or any term from the right side to the left side. In fact, either I should be solving the left hand side, or I should be solving the right hand side, to prove that the right or the left, they are both equal to each other. So here it's just a 1 plus cos theta on the right side, and I cannot solve it any further. I will start solving from the left hand side, which is a sine square theta. So starting from the left hand side, it's sine square theta divided by 1 minus cos theta. Sine square theta, I can write it as a 1 minus cos square theta divided by a 1 minus cos theta. Again, I shall be using the identity for a square minus b square, which is an a minus b and an a plus b. So this means it's 1 minus cos square theta. I can write it as a 1 minus cos theta and a 1 plus cos theta divided by 1 minus cos theta. The 1 minus cos theta, this bracket, they get simplified, and I'm just left with a 1 plus cos theta. And what I can see on my right side, it was given as a 1 plus cos theta, meaning if I solve the left hand side, my result is the same as the right hand side. Therefore, finally, I can say it's the left hand side which is equal to the right hand side, and this is proved here. So part C, it says it's a 2 minus cos square theta, the whole square, minus 4 sine square theta, and this should be equal to cos 4 theta. So I will prefer the left hand to start working from the left hand side, and my left hand side, if I start working from it, it represents 2 minus cos square theta, the whole square, minus 4 sine square theta. Now here I will be using the identity for a minus b the whole square, the algebraic identity, which says that this is equal to a square minus 2ab plus b square. I will be using this identity to 2 minus cos square theta the whole square, where 2 represents a and cos square theta represents a b here. So this means I should be having 2 the whole square minus 2 times cos square theta, and then plus cos square theta the whole square. And then I have a minus 4 sine square theta. So if I solve further, 2 square is a 4 minus 4 cos square theta, and then I have a plus cos 4 theta, and then I have a minus 4 sine square theta. Now what I see here is that on the right side I want a cos to the power 4 theta. I do have a cos to power 4 theta, which means the three terms 4 minus 4 cos square theta and minus 4 sine square theta, I need to solve these three terms to just eliminate them. So let's see what we can do over here. So it's 4 minus 4 cos square theta. I'm writing minus 4 sine square theta, and then it's a plus cos to the power 4 theta here. So I can take this 4 common so that I'm left with 1 minus cos square theta and a minus sine square theta, and then I have a plus cos 4 theta here. Right, so it's a 1. I can take the negative common. I'll be left with a cos square theta plus sine square theta, and then I have a plus cos to the power 4 theta. So again, we know that sine square theta plus cos square theta equals a 1. So I can substitute that here. 1 minus 1 and a plus cos 4 theta. 1 minus 1 is a 0, so it's 4 times 0, which gives you a 0, and I'll be left with a cos to the power 4 theta. So it's just cos to the power 4 theta, and here again I can see that it's the left hand side which equals the right hand side, and it is proved. So this is how these identities questions, these are done to prove the left hand side to the right hand side. So this is how the trigonometric identities are solved, and for the past paper questions you may visit the next video, and till then, Allah Hafiz, take care, and do not forget to like, subscribe and share. Thank you. Thanks a lot.